In today's lesson, we'll be learning about similar triangles. In our previous lesson, we learned that triangles can be similar. In this particular case, we have triangle ABC and triangle DEF. We indicate that they're triangles with this symbol that looks like a triangle. And we indicate that they are similar with this squiggle symbol. This is called a tilde. In similar triangles, corresponding angles are equal. So angle A is equal to angle D. So these two angles are equal. Moreover, angle B is equal to angle E. So these two angles are equal. And last but not least, angle C is equal to angle F. So these two angles are equal. Basically, corresponding angles are equal. However, the side lanes are a little bit more tricky. The ratio of corresponding sides are equal. So here I have the ratio of side AB to side DE. That would mean this side and this side. This is the ratio of AC to DF, so that would be this side and that side. And this is the ratio of BC to EF, which means this side and that side. So if I took the ratios of corresponding sides, they should all be equal if the two triangles are similar. In our first example, we know that these two triangles are similar. Triangle ABC is similar to triangle FED. We also want to determine which angles are equal. So I know that angle B is equal to angle E. How do I know that? Well, they are both 81 degrees. Now, our next angle is 60 degrees, and that's angle A. If you look at the other triangle, you won't see an angle of 60 degrees, but we can probably guess that angle F is 60 degrees. And last but not least, we have angle D, which is 40 degrees. And if you take a look at the triangle on the left, you'll see no angle of 40 degrees. But if I had to guess, that would likely be the same angle. Therefore, I'm going to go ahead and determine which angles are equal. So I'm going to say angle B is equal to angle E. Next, I know that angle A is equal to angle F. And last but not least, angle C is likely equal to angle D. And by using these two similar triangles, you can actually figure out the unknown angles in each of these triangles. So for example, if angle C is equal to angle D, that would mean this is probably 40 degrees. And if angle A is equal to angle F, that would mean this is probably 60 degrees. In our second example, we are told that triangle HIJ is similar to triangle XWV. We also want to determine which angles are equal. So let's start by matching up these corresponding angles. So angle H is 74 degrees, and if you look at the other triangle, angle X is also 74 degrees. Now, this gets a little bit tricky. Over here, I have angle V. Angle V is 32 degrees. We need to find its corresponding angle on the other triangle. Well, my best guess would be angle J. Why do I say angle J? Well, angle J seems to be the narrowest vertex of all the vertices. Next, I'm going to look at angle W, and angle W looks like it's on the shortest side, and angle I is also on the shortest side, so they probably correspond. So let's go ahead and write this down. So I would say angle H is equal to angle X. They're both 74 degrees. I would also make an educated guess that angle J is equal to angle V, which is 32 degrees. And last but not least, angle I is probably equal to angle W. Let's start identifying some of these angles. I already know that angle J and angle V are equal, so that probably means this is 32 degrees. I also know that angle H and angle X are equal, but that's already written in. However, I don't know what angle I and angle W are. Now, you should remember that the interior angles of a triangle adds up to 180 degrees. So if I know two of the three angles, I can easily figure out the third unknown angle. So I'm going to take 180 degrees, I'm going to subtract 32, and I'm also going to subtract 74. When you punch that into your calculator, you should get an answer of 74 degrees, which means this third angle is 74 degrees. So if that angle is 74 degrees, that angle over here is also 74 degrees. And that looks pretty reasonable since the triangles look like isosceles triangles. In our third example, we are told that triangle ABC is similar to triangle DEF. We also want to determine the ratios of corresponding sides. So I'm going to just choose any side to start with. I'm going to choose side CA. If you look at the other triangle, the corresponding side is probably side FD. Now let's take a look at side CB. Again, the corresponding side would probably be FE. And last but not least, if I take a look at the last side, which is AB, the corresponding side should be DE. So let's go ahead and write a ratio. So I'm going to start with side AC. The ratio of side AC to DF is written like so. The side CB corresponds with side FE, so that is how you would write their ratio. And the last side of AB is corresponding to side DE. And last but not least, we just need to put some equal signs in between because ratios of corresponding sides are equal. In our fourth example, we are told that triangle ABC is similar to triangle DEF. We also want to determine the ratios of corresponding sides. So let's begin with any random side. Let's begin with side AB. If you take a look at the other triangle, the corresponding side is probably DE. Now let's take a look at side BC. BC probably corresponds to side EF. And last but not least, I have side AC. Side AC probably corresponds to side DF. So let's go ahead and write our ratios. So side AB corresponds to side DE. Side BC corresponds to side EF. And side AC corresponds to side DF. So like we mentioned in our previous lesson as well as today's lesson, ratio of corresponding sides are equal. In our fifth example, we are told that triangle ABC is similar to triangle PQR. We also want to determine the ratios of corresponding sides. Again, we're going to start with a random side. Let's start with side AC. Now, to find its corresponding side, you're going to have to use the angles. So if you can see, side AC has the angles 41 degrees and 54 degrees. So you want to look at the other triangle and find those angles as well. That would mean that side of PR is the corresponding side. Next, I'm going to take a look at side CB. Side CB has the angles 54 degrees and 85 degrees. You want to figure out what side length has those angles on the other triangle, and that would be QR. And last but not least, I have side AB, which has the angles 41 degrees and 85 degrees. And if you take a look at the other triangle, this also has 41 degrees and 85 degrees, and that is side PQ. So let's go ahead and determine our ratios of corresponding sides. So let's start with side AC. Its corresponding side is PR. Next, I'm going to take a look at side CB, and its corresponding side is RQ. And last but not least, I have side AB, and its corresponding side is PQ. And I'm just going to put an equal sign between these ratios, since ratios of corresponding sides in a similar triangle are equal. In our last example, we are told that triangle CDF is similar to triangle EGF. We want to determine which angles are equal, and we want to determine the ratios of corresponding sides. So let's start with the angles. Right off the bat, we know that angle F in both triangles is 90 degrees. Therefore, those two angles are equal. However, figuring out the other angles are a little bit tricky. So we have angle G. I want to find its corresponding angle. Now, angle G looks like it's located on a side of a triangle which is quite short. And if I take a look at the larger triangle, that looks like angle D is on the shorter side. And last but not least, you have angle E, and angle E looks like it's on a bit of a longer side of the triangle, which leaves us angle C. It probably corresponds to. So let's go ahead and determine which angles are equal. Obviously, angle F is equal to angle F. They're both 90 degrees. Angle G is probably equal to angle D, and angle E is probably equal to angle C. Once we've figured out which angles are equal, we can use these to help us find the corresponding sides. So let's pick a random side. I'm going to choose side EF. Side EF likely corresponds with side CF. You can look at the colors to help you. Next, I'm going to look at side EG. That is called the hypotenuse since it is opposite to the 90-degree angle. And side CD is likely the corresponding side. And last but not least, I'm going to take a look at side GF, and side GF probably corresponds to side DF. So let's go ahead and write our ratios. So let's use these colors to help us. I'm going to start with side EF. So the ratio of side EF to side CF, because those are corresponding sides. Next, I'm going to take a look at side GF, and its corresponding side is DF. And last but not least, I have side EG, and its corresponding side is CD. At this point, I'm going to add an equal sign in between these different ratios because in similar triangles, the ratios of corresponding sides are equal. So just to recap, remember that the corresponding angles in similar triangles are equal, while the ratio of corresponding sides in similar triangles are equal.